Hey y'all, this is Academic Chemistry, Unit 1, Matter and Measurement, and we are continuing Skill 5, which is the International System of Units. This is Section 2 of the notes, and we're going to introduce prefixes. Last class was the cut and paste notes that you guys did without a video, where you just explored what each unit was and what it measures, and now we're going to talk about how to manipulate those measurements. So first, let's talk about what we use in America. So we use what's called the English system, which has feet and miles. And I want you to ask yourself, how many feet are in a mile? Do you know? Chances are you don't know. And that's because the feet to mile unit converters is the stupidest thing that's ever existed. So there's 5,280 feet in 1 mile. Where did that number come from? So the foot came from some king sometime, and they took the measurement of his foot and said, boom, that foot is. And that's kind of stupid because not all feet are created equally, right? So this is how I feel about the English system of measurement. So instead of using this really old school method of measuring things where the units just don't do easy math to convert. So in science, we're going to use the International System of Unit for any kind of quantitative data. So that's data with numbers, 4.8 liters or 75.2 moles. Anything that has a number up front is quantitative. Anything else is going to be qualitative, like a red shirt or something like that. There's no numbers, that's qualitative. You might hear this called the metric system. Chances are good I'm going to call it the metric system. Old school, that's what it was. There's a few differences between the metric system and the SI system. So the metric system has, like, they use Celsius versus in the International System of Units, or SI, System International, which is the French, we use kelvins. But they're pretty much the same thing. And what's great about this is it's based on the base 10. So by using prefixes, we can change the magnitude of that unit. So do you remember how in the English system we had 5,280 feet, it's a weird number in 1 mile? Well, in the metric system, instead of feet and miles, they use meters and kilometers. And 1 kilometer is 1,000 meters. A nice, easy 1 at the beginning, which makes math easy, zeros, which makes math easy. It's 10 to the third. So basically 10 to the third, or 1,000 meters, is a kilometer. All right, so this is just a chart of like a few of the common symbols. It is missing liters for volume, but besides that, they all are there. And this is a meter stick, which I have here, which we're going to talk about a little bit. So if I asked you to describe the distance from here to the moon, and I wanted you to use a meter stick, that'd be really difficult because there's so many meters in it. In fact, there's 384 million meters between where you are right now and the moon, assuming it's right on top of you. Obviously, that changes based on the rotation of the Earth, but that's about right. But look how easy it is to convert to megameters. So mega means 10 to the 6th in itself, or a million. So this is saying 384 mega or million meters within this measurement. And this is a lot easier to digest than all these zeros. Additionally, if you had to write this on a report, it'd be really easy to lose track of some of those zeros. So by using a prefix, it just eliminates that and makes your life a little easier. In case you were wondering what that was in the English system, that's 1,260,000,000 feet, or 283,900 miles. These numbers are so, they're not random, but they look random. You know, there's no consistency between those numbers to make it easy to convert in your head, versus here, the 3, the 8, and the 4 stay the same. The only thing that changes is the 0, or where the decimal is, because it's based on a base 10. So what if you wanted to describe the length of an average bacteria cell? So if I asked you to use the meter stick and measure that, that'd be pretty hard, because the bacteria is so small. You couldn't even see it on the meter stick, so then how the heck are you supposed to measure it? So what it is this, 0.000005 meters. Between the decimal and the 5, there are 5 additional zeros. That is really, 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 really small. In fact, scientists have shown that if you try and think about how small a bacteria cell is, the human brain actually can't process things that small because we can't see it. So we know that it's really small. We can know that it's really small, but to actually be able to think through its size quantitatively, it's not really going to happen. So instead, we use a different scale, and then we just imagine things within that scale. So this is a micrometer. So micro is this prefix here. It kind of looks like a P, but then kind of a U. So if you draw a straight line down and then come back up and draw a U, then that's micro. That's the prefix. Micro means 10 to the negative 6, or divided by 10 6 times. So if my decimal moves from here 6 times over, then that's what it is. That's a micrometer. And then we can think of everything in terms of a micrometer in the microscopic world, and then we can compare things. So we can describe like another bacteria cell is 8 micrometers, and we can think about, oh, how is that in relation to this 5 micrometer bacteria? And then you can really start to understand that world. So prefixes, we've seen already, they go in front of a unit to change the size scale by some factor of 10. And here are all of those prefixes that you can see here. Now you will not need to memorize these in my academic chemistry class. I will give them to you on any test, but you do need to know how to use them. So for example, microgram. If you see this, you see that micro is up front. A prefix is always in the front, and then the gram is always in the back. Well, it could be gram for this one. It could be meters, it could be liters, whatever it is. But it's the prefix and then the base unit. So the prefix says how big or small this is. So micro is our prefix. Then we find micro over here. It's 10 to the negative 6. So that means it's really small. It's saying it's much smaller than a gram. And then G is the base unit. It's what you're measuring. If the micro wasn't there, then it would just be grams. But you can't have micro by itself. Micro is always, or any of these prefixes are always going to be modifying some base unit. So you can have like millimeters, mm, but you can't have, and you can have gigameters, but you can't just have giga. You have to have giga what? Gigaliters, giga meters, giga moles, whatever it happens to be. So a positive exponent means that the thing that you're using to measure is actually bigger than the base unit. So it's multiplied by 10 that many times. So for example, a kilogram. Kilogram is a lot of stuff. So if I were to rewrite this in just using my letters, kilo is K and gram is G. So that's the same thing as 1 kg. Notice these are both lowercase. It's really important to keep track of what things are capital and lowercase in chemistry. Kilo, if you look over here, kilo is 10 to the third. So I can rewrite this as 1 times 10 to the third grams. Notice I replaced the kilo with 10 to the third because it's the same measurement. 10 to the third, 10 times 10 times 10 is technically 1,000. So 1 times 1,000 is 1,000 grams. So a kilogram is 1,000 grams. If you want to think about how big that is, 1 gram is about the mass of a paper clip or so. So 1,000 paper clips is about a kilogram. What about a negative exponent? So if a negative exponent, it means that we're actually measuring something smaller than the base unit. So it's divided by 10 that many times. So a nanoliter, for example. How would I rewrite this with abbreviations? So nano, I see up here, has the symbol N, and liter is a capital L, we know from our last set of notes. So this is going to be 1 NL, with a capital L but a lowercase n. I can also rewrite this, instead of nano, I could put 10 to the negative 9th, so 1 times 10 to the negative 9th liters, which means if I take a liter, so think about like a liter is like a smaller bottle of soda. If I took a tenth of that, and then a tenth of that, a tenth of that, a tenth of that, a tenth of that, and you do that 9 times total, that becomes a nanoliter. It's a very small amount of volume. 0.000000001 liters. Between the decimal place and the 1, there are 8 zeros. It's a really, really teeny tiny little bit of volume of some sort of liquid or gas. It's probably going to be a liquid or gas if it's in liters, generally centimeters cubed or meters cubed, any of those are going to be generally solid, sometimes gases. But, okay, so if we see a nanoliter, we know that is a very, very, very small amount of liquid, most likely. All right, so let's also point out that if this is a very, very small amount of liquid, in fact, it's a billionth of a liter, If I have a billion of them, then it comes back up to 1 liter. So whatever the opposite function of your prefix is, that's how you need to multiply it by to get back to the base unit. So think about it this way. Look at your piece of paper right now that you're writing on. If you were to take that paper and divide it into 4 equal sections, and now you're holding one of those sections, how many of those sections would you need to get back up to a full sheet of paper? You need 4, right? Okay, so a nanoliter is a billionth of a liter. So you would need a billion of them. A billion nanoliters is 1 liter. I just want that to marinate for a bit. We're going to get more into that in the next set of notes. Okay, so these are all the ones I really care about in this class. There's less on here of the prefixes than you saw on that chart you had before, but these are the ones you see a lot. So these are the ones you really need to understand how to use. So a centimeter, if you look at where centi is, a centimeter, centi is 10 to the negative 2. 10 times 10, or 10 to the second power, is 100. So a centimeter is a meter divided into 100 pieces. And if you look at a meter stick, you'll see that centimeters, which are the ones that are numbered, actually go from 0 to 100. Okay? Because it's saying centi is 10 to the negative 2. So it's saying I'm dividing by meter by 10 and then by 10 again. If I just divided it once by 10, it would be a decimeter. And then those pieces I divided by 10 again. Now if I take a centimeter, if you look here at the centimeter, and I divide that by 10, notice that would be a millimeter because I'm dividing by 10 one more time, right? Divided by 10, this is divided by 10 again. And in between here, those little teeny tiny marks are the millimeters because in 1 centimeter I have 10 millimeters. So it's otherwise known as 10 to the negative 2 because the negative exponent means divided by, and 2 is how many times you are. Or you can say divided by 10 and divided by 10 again. Versus a gigabyte. So you guys have probably heard of a gigabyte before when you are getting your data plans, right? And probably didn't know what it was. That's fine. But a gigabyte is a giga, or 10 to the 9th of bytes. 10 to the 9th is 10 times 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 10, or a billion bytes. So if you wanted to get 1 byte of data, your phone wouldn't really do anything. So you need a whole lot of them for your phone to be able to do stuff like connect to the internet or anything important like that. All right, let's finish up. The last thing we need to talk about is scientific notation. So you've probably seen scientific notation before, maybe in your algebra class, but it always follows this format: A times 10 to the B power. A, it's really important, can be 1 or bigger than 1, but it cannot be 10. So this could be 1 times 10 to the 30th. This could be 9.999999999 times 10 to the 30th. But this cannot be 10 times 10 to the 30th. This cannot be 14 times 10 to the 40th. This has to be lower than 1. If you look at this number, there must be 1 digit to the left of the decimal. Okay? No more than 1 digit and no less than 1 digit to the left of the decimal. So let's practice getting out of scientific notation. 5.47 times 10 to the 4th. So since this 4 is positive, it means this number, this coefficient here, needs to get bigger. So we take our decimal and we go 1, 2, 3, 4 spots. And wherever it lands, that's where your decimal is really going to be in the end. Any empty bump gets a 0. So 54,700. This guy, since it's times 10 to the negative 2, it really means divided by 10 twice. So here's where the decimal would move if I divided it by 10 once. And then I'm going to do it again. The decimal is going to come here. Notice between these spots I had 1 empty bump, so it's going to be 0.083. Now this guy is a little weird because this is not proper scientific notation. 9,645 is bigger than 10, so technically it's not correct, but that's okay, so we're taking it out of this notation anyways. Our decimal is here even though we can't see it. We're doing it times 10 to the negative 3, which means it needs to get smaller. 1, 2, 3. So our answer will be 9.645. All right, we're going to finish up with a challenge. So from here to the sun is 150 billion meters. I want you to go ahead and write that in scientific notation, freeze your video, and then come back in a second and see if you have the right answer. All right, so if you did that correctly, then you got 1.5 times 10 to the 11th meters. So the reason for that is, remember, this number here cannot be greater than 10. It can only have one digit to the left of the decimal. So our decimal is here initially. We need to bring it over here, so it's between the 1 and the 5, so that the 1 is that singular digit you have to the left of the decimal. We get to keep the 5. And then you say how many spots over did it move. So between here and here is 11 spots. If I look at the positive or negative, 1.5 times 10 to the, is it positive or negative 11th? Well, does 1.5 need to get bigger or smaller to go back to our original number? It needs to get bigger, so it needs to be a positive exponent. All right, be sure you come find me if you have any questions. We're going to do some practice on this, and then we're going to move on to a new topic. All right, good luck, guys.